Okay, so let's carry on with our exam revision for Foundation 2 Maths. The second topic we need to know is exponents. So what I'm going to do is show you the exponent laws, or the power rules, as sometimes they are called, or indices that you need to know. And then we will do some examples where we combine the different laws. So the first rule is the multiplication rule that says if you have the same bases, you can add the exponents. So an example, if I had a to the, and I'm going to use letters because just to show you that when you start doing algebra and they put letters in, just remember that the letters could be numbers, because I think that when we introduce letters, it gets confusing. But all we just need to know is that they are essentially numbers. They replace numbers, and so they could be anything. So when I get told a to the m times a to the n is equal to a to the m plus n, that is often daunting because we're looking at letters. But if I replace those letters with numbers, and I say, right, 2 to the 3 times 2 to the n, and I make n a different number, so say 2. Now that's a little bit less daunting, but you just notice that the a and then the a represents the 2's. Sorry, let me just make n a different number. Let's make n 4. And so there we have, if I highlight the a's, they represent the 2's. And so when I talk about the same base, they need to have the same bases. That means that these things at the bottom need to be the same. So remember the base being the bottom, right? So the base of a tree is the bottom of the tree. And we can then add them. So I just say, well, it's just going to be the 2, because that was the a, and then the 3 plus 4 is the 7. So if I have 2 to the 3 times 2 to the 7, I can just say 2 to the 7. Okay. Notice the base gets carried through. And we're going to do the same thing with the base. So we'll say 2 to the, let's make them the same as what we did before. So let's say we said 2 to the 3 divided by, we'll write the rule in first, a to the m divided by a to the n. With the same basis, we just subtract. So that's m minus n. We just subtract. Okay, so if I had a 2 to the 3 divided by 2 to the 4, I would then say just 2 to the 3 minus 4. 3 minus 4, the minus is more negative, so it's actually negative 1. Okay, now this brings me up, let's just highlight the bases. So we notice we have the same bases, there, and there. So the bases must be the same for us to be able to do this. If this was a 3 to the 4, we couldn't do it. Now, they don't like us to have negative exponents. So the rule we're going to be doing after this will be the idea that this 2 can become a positive exponent if we simply move it to the bottom. So 2 to the minus 1 is essentially 2 to the minus 1. Now we know that every number has a ghost 1 underneath. In other words, 10 we know is actually 10 over 1. We call it a ghost 1 because it's there and we don't see it. So if we were to write 10 as a fraction, we write it as 10 over 1, which is obviously completely different to 1 over 10. But this allows us then, if we were to then multiply fractions later, so say we had the thing of 10 times 2 over 4, right? We can actually write it as 10 over 1 like that. And so we can time these fractions because we could cancel the 10 and the 4, because 10 divided by 2 is 5 and 4 divided by 2 is 2. And then we could also cancel the 2 and the 2. Yeah, 2 and 1. And so we end up with 5 times 1. Okay, that's fractions. We'll get into that on the, I think it's a later topic. But the important bit is that this 2 to the minus 1 over 2 can essentially be written as 2 to the minus 1 over 1. And then because they don't like negative exponents, we could simply move this 2 to the minus 1, and I'm going to do this in pink. Say we move it to the bottom, it becomes 2 to the plus 1. Okay, so we'll more about that in another. And so when this has gone to the bottom, essentially we've only got we've only got 1 at the top. 1 is like a placeholder. So it becomes 1 over 2 to the 1, and anything to the power of 1 is just itself, right? So 3 to the 1 is 3. And again, this idea of a ghost, right? So the 3, we know there's this ghost 1 here. So if you just see the number 3, we know that there's actually 3 to the 1. If we were to write it as an exponent, we don't, because it's the default is 1. So again, just like there's a ghost over here, a ghost 1 at the bottom, there's also a ghost 1 here. Right? It's there, but we can't see it. So we call it a ghost. Okay, so 3 is like that. And so this 2 to the 1, that is a ghost 1. So we actually just write it as 1 over 2. Okay, so the rule there was for division is we subtract the m and n, but we also then introduce this other rule, which is coming next. I'm going to do one more of these division ones. Let's say it was 3 to the 4 divided by 3 to the 2. A little bit more simple. We say 4 minus 2 is 2, and so it'll just be 3 squared, and that we don't have to have this complicated negative 1 that we're going to deal with. I put on the side here an important rule that anything to the power of 0 is 1, right? So 2 to the 0 is just 1. But I could also have x, y, z to the 0, and that's also just 1. So anything to the power of 0 is 1. If I was to have x to the 0, y, z, this x bit is the bit that's to the 0, and so it'll be 1 times y times z, right? So 1 yz, which is just yz. So we notice that the x to the 0 bit just becomes 1, and so 1 times yz is just yz. So anything to the power of 0 is 1. Now let's look at the power rule. Well, obviously the power rule is the same base, because actually there's only one thing that has a base, and that's so we have, let's say it was a to the mn, sorry, a to the m to the n, like that, is equal to a to the m times n. So when the base is, when it was a to the m times a to the n, when we added, here what we're doing is if it's to the power of mn, we then times it. So if this was a 2 and this was a 3, we say a to the 2 times 3, which is a to the 6. Or if we would just put a number here, 3 squared to the power of 3, we have at 3 to the 2 times 3, which is 6, 3 to the 6. Okay, I could actually, if I wanted to expand this to prove it, we know that 3 times 3 is 3 squared, and then to the power of 3. Now what we end up having is each of these, when you have a bracket, both of the things inside the bracket get the power. So it becomes 3 to the 3 times 3 to the 3. And again, here we're using our addition rule, the first rule. 3 plus 3 is 3, and so we see we get the 3 to the 6. Okay, so that's the power rule. Now, they do sometimes try and confuse you by doing a to the m times a to the n. Now, this is not the power rule. This is the multiplication rule, because the a to the m, the n is not over here. It's over here to the power of the a. So when you see the brackets, this is actually just a to the m times a to the n, which is our a to the m plus n. So this is actually our first rule, where we add the exponents. So just be careful of that. Be careful of this, getting confused. This is not the power rule. This is the multiplication rule. Over here, where we add the exponents. Okay, now we've dealt with negative exponents. So this is the idea that if you have an exponent, so if you have m to the negative n, you can actually take this and put it to the bottom and make it a plus n. So for example, we did earlier 2 to the minus 1. Let's say it was 2 to the negative 3. We could make this 1 over 2 to the 3. And you can jump up and down between these sides. So let's say I had a to the m. Let's make it numbers. To the negative 2. B to the 2. Sorry, b to the negative 2. C to the negative 4. What I can do is these things can jump around. The a to the minus 2 could jump to the bottom. So let me do these in colors. So a to the minus 2 could jump to the bottom, become a to the plus 2. C to the minus 4 could jump to the top and become c to the plus 4. And b to the minus 2 could jump to the bottom and become b to the plus 2. And so this idea that negative exponents can jump like this. And so you can go to the top and become positive if you are negative at the bottom. Or if you're negative at the top, you jump to the bottom and become positive. And that's how they like you to answer things. They always want positive exponents. Okay. One final rule I want to just cover, although you may not have to do it, is a to the root. So the square root is actually just a to the half. So you could deal with this as, so if you were to have, say, a to the 2 times a to the half, essentially that would be a to the 2, a to the half times a to the 2. I've written it the opposite way around because I haven't got space here. But you end up having a to the half plus 2, which is 5 over 2, if we add these two together. We add these two together, we get 5 over 2. Might have lost you there. That was quite confusing. Let me just do the rule. So a to the m to the root n. So if you see this, if you see something like a to the 4, like this, all of these rules have been we've been dealing with exponents. And so it's like when you get something like this, if you turn it to an exponent, it's going to be much easier. And so what we do is the 4, because it's the a to the 4 at the top, we think of it as 4 there and 3 there at the bottom. So it becomes to the power of a fraction. So remember, the 4 goes to the top and this 3 is at the bottom. Okay, so if we were to look at an example here, let's do an example like this. Let's do 4 to the 2. So what we could just write this as is 2, and then remember the 2 is at the top and the 4 is at the bottom. And so 2 over 4 is essentially actually a half, and that's 2 to the half. Okay, so it's easier to deal with it as a power than this. If I was to do it the other way around, 2 to the 4 to the 2 here, this is essentially then, it will be 2 to the 4 over 2, which is 2 to the 2, which is 4. Now we can prove this because we know 2 to the 4 is essentially 2 times 2 times 2 times 2. And we know 2 times 2 is 4 times 2 is 8 times 2 is 16. And so 16. Now, I don't need to put a 2 here, by the way. This is a 2. So that, remember that the ghost square root sign, there's actually essentially a ghost 2 here. So in other words, if I have the square root of 4, this is essentially, there's a 2 here. But I don't write the 2. But I do write a 3. So if it was a 3, I write the 3. But if I don't have anything, I know that it's a 2. It goes to 2 here. So the default is a 2. Well, we know that the square root of 16 is 4 because 4 times 4 is 16. And so you see we get that same answer there, 4 and 4. Okay, so let's run through those, the important ones, because I think it may have gotten. Okay, so the multiplication rule, we add the bases. The division rule, we subtract the base. We add the exponents. Division rule, we subtract. The power rule, we times. Negative exponents can jump up and down. The square root thing, here, if I lost you there, don't worry. We can go over that again. But let's just deal with the first few rules. So 2 to the 2 times 2 to the 3. So now get your piece of paper and try and do these by yourself. 2 to the 2. So here we're adding them. So we have 2 to the 5. Remember, because we add the 2 and the 3 over here. And then the 2 to the 4. And so we have 2 to the 5 over 2 to the 4. Now, essentially, 2 to the 5 over 2 to the 4 is the same as saying 2 to the 5 divided by 2 to the 4. And we know that with fractions, we subtract. So 5 minus 4 is 1. And so we end up just with 2. Another way of looking at it is just saying 5 of these, 5 minus 4 gives us 1. So 4 of these cancel with 5 of them to just leave 1 here. So whichever is easiest for you to look at. Now what I'm illustrating here is that if you get letters, so notice here the 2's are the same as the A's. So let me highlight that. So I have a 2, 2, 2, and 2, 2, 2. I notice it's 2 to the 2, A to the 3, A to the 4. Don't be scared of the letters, it's the same thing. So it'll just be A to the 5 over A to the 4. And so that gives us the same, just A to the 1. Because 5 minus 4 is 1, and this is a ghost one, so we can just write A. Here we subtract. So we have A to the 3 minus 2 over A to the 4. So we have A, 3 minus 2 is 1 over A to the 4. Now this, we can think of as we're going to have 3 left at the bottom. Because if you have 1 here, 4 minus 1 is 3. So this A, there'll be a 1 replacing it here because essentially I need 3 A's at the bottom. So what I'm saying is this 1 got subtracted from here, 4 minus 1. And so 4 minus 1 is 3. And so this, when you remove all the letters from the top, you need something at the top, so there has to be a 1 there. So this 1 is like a placeholder because all the letters have gone away. And we can't have like 0 over A to the 3 because that would just be 0. So there's always a 1 there. Let me just do another example. Let's say that we had A over A. Well, these cancel to give us 1. Essentially, we have 1 over 1. We don't have 0 over 1 if we have A over A. Okay. If I have A over 2, again, 2, and there's essentially 1 there. There's more A's at the bottom, so the A will be left at the bottom, and we'll have to just leave a 1 here. Okay, some of you may do this a little bit differently. You may say, you may go from this over here. Just going to do this again. So you may have a over 1, a to the 4 like this, and you may say, okay, it's a 1, and then I was essentially dividing by a to the 4. And we know from division, we subtract. So we say a1 minus 4, which is a to the minus 3. And we know that that can be written as, because it's negative, we can shift it to the bottom, because it's a to the negative 3 over 1. We essentially write it as a to the 3. So we see we get that same answer a different way. So whichever way you do it is fine, whatever makes sense to you. Now, we need the bases to be the same for us to add. So look at this. We've got the A's together, right? So these A's. So let's do the like bases. We'll highlight them and so the A's are in blue. And so 2 plus 4 is 6 over B A to the 3, and then there's the B. So we've dealt with the A's. Now let's look at the 6, the other A's. So here, let's do the A's in blue again, over here. And here it's dividing, right? 6 divided by a to the 6 divided by a to the 3. So what's 6 minus 3 is 3. So we'll end up with the top being equal to a to the 3. And then the B is 3 minus, and there's a 1 here, right? So let's do the B's in yellow. So we're dealing with the like bases independently. And so 3 minus 1 is 2. Okay. Negative 3 plus 2. So minus 3, that plus 2 equals minus 1. Okay, so a to the negative 3 plus 2, because we're timesing, over a to the minus 5. And so we have a to the minus 5. Now, this is a bit confusing to deal with, but we know that when we have negative exponents, they can jump around. Remember that? So a to the minus 5 could jump to the top and become a to the plus 5. A to the minus 1 could jump to the bottom and become a to the 1. And so here we've got a to the, I'll do it in the colors, the 5 at the top, minus the 1, because the 1 goes to the top, becomes minus. So we have a to the 4. So we're starting to do more complex questions, but we deal with them simply. So here, this is not the power rule, because it's a to the 3 times a to the 2. So we're saying a to the 3 plus 2 over a to the 6, which becomes a to the 5 over a to the 6. Now we notice the bigger number is at the bottom. So essentially we could take this 5 to the bottom, becomes 6 minus 5, which would be 1. So it'd be a to the 1, which we can just write as a. And remember, when this jumps to the bottom, we have to leave a placeholder here. So when this jumps to the bottom and becomes minus 5 at 5. We've taken all the a's, and so we need a placeholder here. So 6 minus 5 is 1, and we've got that placeholder. And remember, 1 is a ghost 1, so we simply just write it as 1 over a. Okay, it gets more and more complicated as we go. So when we divide, we're subtracting. So what we're essentially saying is, let's deal with the bases that are the same independently. So we'll do the blue, the A's together first. So we've got the A's here. And so we have a to the 2 Divide means minus. Let's do the B's next in green. B's and B's. Well, there we go. B to the 3 minus 3. So because we have this bracket, by the way, and because we have this bracket, everything gets the division. So we do the minus 3 and the minus 2. So let's do the C's as well. And so we have times C to the 7 minus 2. Okay, so now we have A, 2 minus 4 is minus 2, right? Because the minus, it's more minus. So from topic 1, we know that our integers, it's the same as saying minus 4 plus 2. And so it's 4 minus 2 is 2, but remember the negative is bigger, so it's a negative 2. B to the 3 minus 3 is B to the 0, which we know later is going to become 1 because anything to the power of 0 is 1, and then C to the 7 minus 2 is C to the 5. Okay, now we have to deal with these as well, just to tidy this up. So now A to the minus 2 is going to go to the bottom, because remember there's a ghost 1 here. So A is going to go to the bottom and become A to the 2. B to the 0 is just 1. And C to the 5, remember, and I don't really need to write the 1 because I'm going to have a C5 here. C5 stays at the top. So that's B to the 0. We don't actually write 1 C5. We just write C5. So even though there was a 1, we don't have to write it. So a lot of students write the 1. They don't need to. Don't need to write the 1 if there's something else at the top. If there was no C5, we would write the 1 because we need to show that there's something at the top. This one, to the power of 0, all of this complicated stuff we don't have to worry about. Because if we go back to here, anything to the power of 0 is 1. So anything to the power of 0 is 1. So this is simply just 1. Nice. A to the 0. Okay, so now let's look at this. We've got an exponent on the outside, so everything gets the 4. So A to the 0 times 4 is just A to the 0. Let's do the B. Let's do this in blue. B to the 3 times 4. And then let's do the C. C to the 6, that'll be C to the 6 times 4. Now the A to the 0, that's just 1. So that 1 times whatever this will be will just be 1. So we don't have to write the 1. And we get the B to the 12, C to the 24. That's done. Okay, the last one is just a little trick that we're going to do. Now, when we have a negative exponent to the top of a bracket, we know that A to the negative 2, things can just jump to the bottom and become A to the 2. So I could make this A to the minus 2, B to the minus 2, C to the minus 2. Because everything in this gets the minus 2. A to the 2 times minus 2. B to the 3 times minus 2. C to the 2 times. I'm doing it the long way because then I'm going to show you the trick afterwards. So essentially what could happen is this A to the minus 2 could go to the bottom and become A to the plus 2. And B to the minus 2 would go to the bottom and become B to the plus 2. That's super complicated. So rather, first, deal with the inside. And then we're going to do a little trick. So we notice that the 2 is bigger than the 1. So at the bottom, we're going to have 2 minus the 1. So let's do the B's in blue. So we have at the bottom, a to the 2 minus 1, which would just be 1. The b is also bigger at the bottom. 3 and 1. So b to the 3 minus 1 is b to the 2. And c to the 2 minus 1 is c. But we need something at the top. Remember, we need that placeholder because all the letters have disappeared. Now, because this is a minus 2, the trick is I can actually flip this and make it plus 2. So I could write it as a plus 2, and then I simply put the a and now because I'm taking all of these to the top, so the b to the 2 also goes to the top and becomes b squared, and the c goes to the top and becomes positive. So what have I done? I've simply moved this whole ABC to the top and changed this to a positive 2. So that I can do because of that rule about our negative exponents over here. Okay, and then finally, I can use the power rule, right? So a to the 1 times 2 is a squared. B to the 2 times 2 is b to the 4. And c to the 1 times 2 is c squared. Wait a minute. This was oh no, that's fine. Yeah. Okay, so that's the final answer, right? So there is our exponents. And yeah, next we'll be doing topic 3.